Hello students, today we will learn number system. So in this number system, how to convert a decimal to binary, then binary to decimal, then comes arithmetic, binary arithmetics, we'll see. Okay, so octal number system, hexadecimal number system, everything comes. So we'll see one by one. Before learning this, so I hope you should know the tables. So then only easily you can perform the binary operation and the division methods and all. So if you do not know the tables, please learn the table. So that learning table is very important to solve the sums. So now first introduction part. So in the earlier times when there were no means of counting, so in earlier days when there were no any methods to count, so in that case people used fingers or stones or pebbles or sticks. So that are the objects they used to count. Okay, for counting people are using that. So these methods were not adequate. So means that whatever the method they are following with the fingers, sticks, pebbles and all, so that is not adequate means that is not suitable for counting. So to overcome that problem, many number systems have introduced with the passage of time. So that is a decimal number system, binary number system, octal number system, then hexadecimal number system. Now what is number system? A number system is a set of values used to represent different quantities. A number system, it is a set of value. So that values are used to represent the quantities. Quantity in the sense, for example, number of students. How many students are there in a class? Usually we will say one number. So how many people are watching the movie? We will say one number. So that is representing the quantity. Okay. We humans use decimal number system. Now present day whatever we are using, so that is decimal number system. So in that number system we have total 9 digits. Okay. So keep it in your mind. A computer represents all kinds of data and information in binary number system. See, we are using decimal number system, but computer uses a binary number system. Understood? The computer doesn't know decimal number system. The total number of digits, total how many digits are there in that system, so that is called as base, or that is called as radix. Got it? So if you have 10 digits means that is 10 is the base. If you have 2 digits means 2 is the base. If you have 8 digits means that is 8 is the base. If you have 16 digits means 16 is the base. So that base or radix, total how many digits are there in that number, so that is the base or radix. Now decimal number system. The need for counting paved the way to introduce decimal number system in which 0 to 9 are used to form a number. Most of our arithmetic operations are performed with the decimal numbers. So here in mathematics and all, see, we are using decimal number systems only. So there total we have 10 digits, so that is 0 to 9, and each number can be written individually, or you can group that digits and you can form the number. Like you can make you can form 2 digit number or 3 digit number, 4 digit number. Means you are grouping that digits. You are grouping the digits and you are forming the new number. Got it? So some examples are given here: 82, 256, 52.87. These are some examples for this one, decimal number system. Totally it consists 10 digits. So base is 10. Now here the value of each digit in a number depends upon the following. So here they have given some points. The face value of the digit. What is the face value of that given number? And what is the base of that number system? And what is the position of that number? What is the position of the digit in that number? So these all matters. Understood? So one example is given, that is 547. This is actually you have learnt in a mathematics. So what is the place values of each digit? Understood? I am not going to explain that. So directly I will go to binary number system. So binary number system consists only 2 digits. It consists only 2 digits, that is 0 and 1, and it has a base 2. Why 2? Because only 2 digits are there. That's why it is 2, 0 and 1, only 2 digits. So that's why base is 2. Since this system uses 2 digits, it has the base 2. All digital computers use this number system and convert the input data from the decimal format into its binary equivalent. Now present day all the systems uses this number system, and it converts that input data in the form of 0 and 1, in the form of binary. Understood? Computer doesn't know decimal number system, it knows only binary number system, but we are giving the instruction in English language, and that will be converted in the form of zeros and 1. So that is the point is given here. Next point, why binary? Because digital computers nowadays, what we are using, that computers knows only binary numbers. Understood? All digital computers use this number system and convert the input data from the decimal format into its binary equivalent. Now whatever the input we are giving, that input will be converted in the form of binary. A computer cannot understand human language, means computer doesn't know English language, rather it understands only the binary code, it understands only 0 and 1. Therefore the data that is entered into a computer is converted into its binary equivalent. Now we are giving the instruction in the English, but computer doesn't know. Now in that case, in the computer the given instructions will be converted in the form of zeros and ones. Now how to convert decimal number into binary? So here some rules are given. If you want to convert decimal number into binary, first you have to divide that number with 2, with the base 2. Why 2? Because in a binary we have only 2 digits, so that's why you have to divide that number with 2. Write down the remainder and divide the quotient again by 2. So now you have to go on divide that number with 2. So 2, the number why we are dividing with 2, because only 2 digits are there in a binary, so that's why. And whatever the remainder you are getting, so that remainder you have to write it to the right side. If you are getting 0, then you have to write 0, don't leave it. If remainder 0 means don't leave it, you have to mention that 0 also. You are going to get 1 or 0 only, you may be getting 1 or you may be getting 0, only this 2 digits you are going to get as a remainder. Repeat the step 2 till the quotient is 0. So you have to continuously repeat that continuously until you get that last digit 1, last digit 1 or 0. Understood? So continuously that process has to be continuous, division process. Write the remainder obtained in each step in the reverse order to form the binary equivalent of the given decimal number. So after dividing, whatever the reminders you have written to the right side, so that reminder you have to write it in reverse order, so that is given here. So write that reminders in a reverse order to form the binary number. So that's why placing the least significant digit at the top and the most significant digit at the bottom. So after dividing you are getting the reminders are written at the right side, and you write that reminders in a reverse order. So let us see in an example.